So this is the second example that I'd like to discuss on dissipative signaling. So it has to do with incomplete insurance in the context actually of an IPO. So here's an example. So this is a number of years ago when Mark Zuckerberg sold part of took his company to the stock exchange, took it public. But he said in the meantime, so I'm really convinced about Facebook being a very profitable company. So he says, I'm going to hold on to my own stock for the next 12 months. So what's the meaning of this commitment? So why might this inspire confidence in investors to pay a lot of money actually for the stock themselves? So the idea here is going to be, well, this is going to be costly to some extent to Mark Zuckerberg. So he might prefer to sell his stock immediately and use the money, the proceeds of this to invest in some diversified portfolio because he might be risk averse, or perhaps to use some of the money as liquidity. So he might have some other use of the money, but he says, no, I'm going to keep this stock just as it is because I'm really to demonstrate basically that the stock in Facebook is worth a lot. So we look at the model which actually rationalizes that in terms of costly signaling. So the model that we'll look at actually now will deal with incomplete insurance and with risk aversion. So in this model, as unlike actually a large part of the rest of the course, we're going to look at entrepreneurs who are actually risk averse. So they prefer to diversify their portfolios or to have money rather than stock which have uncertain outcomes. So this entrepreneur would like to sell an equity stake because they prefer the certain share price that they get now over the uncertain but expected future cash flows. That's what risk aversion does, right? You prefer to get the money rather than the uncertain outcome of the stock in the future. So the idea is, if you now sell your equity stake already at its expected value, it will provide you against insurance against bad outcomes, and this insurance to you as risk-averse entrepreneur, a risk-averse person, risk-averse individual, is going to be valuable. So it's going to happen that if there's no asymmetric information, so everybody knows which stocks are worth good value for money and which are sort of slightly lower value stocks, then both if you have a high quality and if you have a low quality firm that you're selling, you would like to sell actually a large part, if not the entire firm. Why? Because you prefer getting the expected payment of those stocks today rather than getting the uncertain cash flow with perhaps higher outcomes but also lower outcomes tomorrow or next year. So selling off all your stocks will fully insure you against the uncertain future outcomes of those stocks that you have today. So what we'll see is if there is hidden information or asymmetric information, then investors cannot distinguish which stocks are good and which stocks are going to be bad. The entrepreneur has some better idea about whether the firm is a high quality firm or a lower quality firm. But we'll see that by keeping some equity in the form of stocks rather than selling everything in the market, the entrepreneur can signal their own trust, their own confidence in their own firm. And you'll also see, like in the costly signaling that we had in terms of the costly collateral, it's going to be more costly for a genuinely bad entrepreneur who knows that the value of the firm is actually not that high to mimic this strategy. And as a result, we'll figure out that there's again this separating equilibrium where the price for issuing stock for a good firm is really going to be different from the price that you get from the market from issuing stock from a bad type of firm. So the information that the entrepreneur has on the future profitability of the firm is going to be revealed in the market by the fact that essentially that they keep some of the stock in their own portfolio rather than selling all the stock. at once. So there's a model to this again in Tyrol, application 8 and in section 6.3. So in the slide I will actually use that model but follow a slightly different version of that, particularly the version of by Leland and Pyle, which was the original model, actually slightly different than the form that it is in the book. So have a look at both, I suggest. So the model here is, there's this firm, and the firm has future cash flows which are uncertain. So they're different in terms of good firms having a high expected cash flow, so the expectation of the tomorrow's or next year's cash flows is high, or RG, the good outcome, whereas bad firms have a lower expected cash flow, RB. So RB is smaller than RG. Furthermore, for either type of firm, the outcome is uncertain. So there's some variance that's associated to this R. So it might be a bit higher than the average or the expected outcome, but also might be a bit lower, and the variance will just normalize as sigma squared. It will be the same for both types of firm. We're going to look at, as I mentioned, entrepreneurs which are risk averse, because that's going to drive the result that we have in this model. So what's the utility from holding on to this stock? So if you have this stock, then of course you will be happy with the return that you get next year. So that's ignoring some discounting here. The expected value of R, that's what your utility is going to be. But there is a cost here of holding on to this stock, which is related to the uncertainty or with the variance of the stock. I'm going to model this utility as mean variance utility, which says I'm happy with a higher mean, but I'm actually less happy with a higher variance. I don't like variance. That's what risk aversion basically means. So I'm going to subtract a half times the variance, or half times sigma squared, if you wish. So this is going to be different for good and for bad type entrepreneurs, in the sense of the good type having a higher expected return, namely this RG, than the bad types. They have the lower expected return, RB. And the variance part here is the same for both. Sigma squared is the same for both types. Okay, so what would you like to do? You dislike risk, you're the entrepreneur, you don't like the risk. So what can you do? You can sell your shares. And fortunately, there's a bunch of risk-neutral investors, so they are actually willing to pay a price commensurate with the expectation of the cash flow, and they don't care that much, or they don't care at all actually for the variance. They're willing to pay the price for the expected outcome of the future cash flow. And this price we're going to call S. It's going to be the stock price. So what you'll do is, you can, in general, as an entrepreneur, you might want to keep a fraction of shares in your own pocket, delta, and only sell off 1 minus delta. And if you do that, so what would your utility be? Well, since you sold off 1 minus delta of your shares to the risk-neutral investors, for that 1 minus delta shares, you get the stock price S. But the remainder of the shares, the delta remaining share, you keep on your own books, in your own portfolio. And there you are, so exposed to the outcome of the stock itself. So you do like the fact that you do get your expected return R on delta of these stocks. So that's a delta times the expected value of R. But now you're exposed to this sigma squared risk. The variance, of course, of a position which is delta, size delta, variance is something quadratic, so the variance grows actually with delta squared. So if you keep half of your stock on your book, then the variance associated that will be half squared times the variance of 100% of your stock. Hence the delta squared in this variance term over here. Variance is a quadratic notion. So this is your utility if you sell off delta, or if you keep delta of your shares and you sell 1 minus delta of your shares to these outside investors for a stock price S. So let's look again, like we did before, at first at the benchmark. So the benchmark of complete information. No hidden information. Everybody knows which companies are good quality, which companies are bad quality. So if you're a risk neutral investor, you see these good quality shares on the market, you will be willing to pay a share price SG, which is equal to the expected cash flow of these good quality stocks. And vice versa, if you see a low quality, the bad entrepreneur offering their stock onto the market, you'll still be willing to pay a stock price SB, which is going to be equal to the expectation of this lower quality RB stocks. So suppose you're a good type, everybody knows you're a good type. How much of your stock would you be willing to sell at this price SG, which is equal to the expected value of the future cash flow, because these investors are risk neutral? Well, in general, you get utility from selling 1 minus delta of your stock and keeping delta on your book. Well, 1 minus delta is what you sell. For those, you get the amount SG, expected value of the stock. The delta part, the fraction delta that you keep on your own books, for those you will get the expected return, but you will be exposed to the uncertainty, to the variance, which is sort of harmful to you because you're risk averse. Was this factor this term minus a half delta squared sigma squared with this mean variance utility formulation. And if you add those up, so since SG, the share price, everybody knows is a good firm, share price equal to the expected outcome, RG. If you add these two up, you will see it's just RG. So total utility will be RG minus this variance term, a half delta squared sigma squared. Well, you want to maximize your utility of the good type. Everybody knows your project is good. How many shares will you keep on your portfolio in order to maximize your utility? Well, you want to make this delta, the stuff that you keep on your own books, as small as possible. And that's going to be delta equals 0, obviously. So you will get complete insurance in this case. You're completely insured against these future fluctuations in the stocks, and basically you've completely cashed out on your stocks. So this is what you'll do with perfect information, without any hidden information. And similarly, that's what the bad types will do as well with perfect information. So what's going to happen when there's asymmetric information? Well, in this case, the outcome in which everybody sells all their stocks cannot be a separating equilibrium. Because if investors are just going to believe what you say, they will be willing to pay RG for a good type stock and RB for somebody who claims bad type. Well, in this case, if you have a bad company, a bad firm, a low quality firm, you will always lie and get the higher share price, sell all your stocks at actually the RG. Of course, that cannot be the equilibrium because investors will anticipate this and they will not fall into that trap, and they will actually say, well, if everybody's going to sell all their stocks, then I'm going to update my beliefs and just assume that if somebody comes to me, it will on average be a good type investor with fraction alpha, on average be a bad type investor with fraction 1 minus alpha, and I'm only willing to pay for this stock with the average value of the stock, which we'll call the pooling value. Share price will be the pooling share price. And again, as in the first part of the lecture, we'll see good types here cross-subsidizing the bad types. So if you are genuinely a good investor, a good entrepreneur, a good type, you own the good type firm, you might be unhappy about this and would like to do better. So now asking, can we signal that we actually are a good type? And can we use essentially this risk aversion to make this signal a credible signal? So what we're going to do as a good type is we're going to signal by keeping some fraction delta of the stock, perhaps not the whole stock, the whole 100% of the stock, but a part of it on our books to convince investors that this is actually a good company, just like Mark Zuckerberg did with the Facebook stock. So in that case, if the investors believe this, so if this is going to be an equilibrium, a sustainable equilibrium, then the investors will see this delta, oh, they keep their stock on their books, so this must be a good firm. So I'm willing to pay SG equal to the expected stock price equal to the expected value of this cash flow RG, the higher expected value. Well, we do have to make sure that bad entrepreneurs are not going to be willing to copy that behavior and also keep this delta on their books. So what we would like to see is that if they copy, we again have this no mimicking constraint here. If they copy, what do they get? Well, they retain a fraction delta of their stock on their own, in their own portfolio. So they know this is a bad quality project. So for that part of their portfolio, they will get an expected return RB, delta times RB. They also keep the stocks, this fraction delta on their own book, and they are exposed to the variance, so they are exposed to this risk. And finally, there's a sell of 1 minus delta to the investors at this hypothetical RG stock price. And what we would like to have is that the utility that they get, so the joint combination of these three terms, to be lower than what they get if they just come clean and say, well, sure, I have the lower quality stock, just take all my stock and pay RB for it. I'm satisfied with a share price RB share price as equal to RB. So that's what they would get if they admit being of bad type and sell all their stocks, no longer being exposed to the residual risk here. So this is the constraint. It's going to be a constraint on how large this delta is going to be, so how much the fraction of stock that good types need to keep on their book to discourage bad entrepreneurs from copying their behavior, how large that delta needs to be. Well, if you work out the threshold value for delta that's going to satisfy this, so we want to take the lowest delta while still being able to verify this no mimicking constraint over here. If you work that out, and you should do this by yourself now, you'll find that this delta will satisfy a half times delta squared sigma squared. So this term actually needs to be equal to 1 minus delta for the solution times RG minus RB by rearranging these this inequality over here. This equality will make sure that it holds with equality, obviously, as before. So by rearranging, this will be the conditional delta. And I'm sure that using the ABC formula, you'll be able to actually compute what this delta is. It will be a number, as I'm sure you can convince yourself of, that is going to be in between 0 and 1. So there is some delta between 0 and 1, which is going to make sure that bad types, so bad project owners, are going to be preferring to tell the truth, to say, yeah, sure, I'm a bad type, I just want to sell all my stock, and I'm satisfied now with this lower RB that I get for my stock. Whereas the good types will be better off by getting the higher share price, RG, at the cost of keeping this particular fraction delta, delta star here, which is the solution to that equation, to that quadratic equation, on their own books and being exposed to that risk, so at the cost of incomplete insurance. Again, you can look at this in a picture. So the full information benchmark contracts would be, we're selling off everything, so keeping nothing on our books, so the bad entrepreneur getting the low stock price RB, but no delta, nothing on their book, while the good entrepreneur gets the high stock price RG, with still nothing on the book. Well, that's not sustainable in equilibrium when there's hidden information, because then the bad type would say, oh, I actually prefer something which lies above my indifference curves, namely this good project. So what do we have to do? We have to, as good entrepreneurs, we have to keep some of this delta, in particular fraction delta G of the stock on our own books, keep being exposed to the risk into those stocks to make sure that indeed the bad types are not enticed to actually mimic the good types. No mimicking constraint will be satisfied, and that will result in the separating equilibrium in which the good types will offer this particular contract with a nice high payoff RG for their stocks, but while keeping at the expense of keeping a fraction delta of the stocks in their own portfolio and being exposed to that risk, so not being completely insured against that risk. So we have this separating equilibrium. So good entrepreneurs write different contracts, do different things than bad entrepreneurs do. So good entrepreneurs keep some fraction delta on their own book, only sell 1 minus delta star to the investors, while bad entrepreneurs reveal their true type, so they reveal that they are of the bad type and sell all their equity, but at a lower price RB. So again, this costly in the sense that, in terms of insurance, it would have been best if every risk-averse entrepreneur would sell all their stock to the risk-neutral investors. But well, that won't be in equilibrium because that would make bad types copy this. So this is signaling, so it's costly because it's inefficient, but it's signaling, it is working because for bad types it's even more costly to hold on to their own shares because they know that they are actually bad types and the payoff will be lower than RG. So the question was, can we design in this case a scheme such that this good entrepreneur can again signal that they have this high quality project, the high quality firm. In this case, the signaling device, the mechanism through which the signal is holding on to part of the equity of their firms when bringing this firm to the market. So these were financing examples of signaling. Of course, signaling is not exclusive to financing, so there are other parts in economics, obviously, where signaling might work. There's also interesting parts in biology, even where signaling works. And this final picture actually gives an example of signaling in biology that survived evolution, if you wish. You see this peacock, this nice peacock. It's trying to impress this peahen, I suppose, here, by showing this enormous and nice tail. So you can see what this peacock says. I'm a very good quality. I have good quality genes. Essentially, I can grow this enormously long tail. It's costly to me because with this long tail, I will be slower in the forest when the fox is chasing me. But believe me, I am so strong that I can actually afford doing this. So I'm the peacock for you, peahen. So this is a biology equivalent to the signaling that our entrepreneurs did in the finance example. Okay, so as wrap up, we've looked at financing now with hidden information, asymmetric hidden information. We first looked at pooling. So with pooling, everybody gets, good and bad types get the same contract. So there's cross subsidies from good to bad types, and there might be actually underinvestment or overinvestment. Good entrepreneurs will be worse off under pooling, so they might try to remedy this by signaling, separating from the bad types. The signal is typically going to be costly for them, but is necessary in order to meet these no mimicking constraints. So make sure that indeed bad types will not be willing in equilibrium to copy their behavior. So that's where we'll end this case, this time. So next week we are going to go back to the moral hazard model. So we'll leave alone the hidden information, go back to the hidden action model with the private benefits B and the PH and PL. But in that case, we'll look at some additional agents that are going to be coming in and who are going to do monitoring. So they're going to check on the entrepreneur to see whether they are actually doing the effort that they promised to do. I'll see you next time.